Hey everybody, so in this video we're going to talk about writing electron configurations. So before we can begin, let's talk about what an electron configuration is first of all. So electron configurations are a way of describing the location of electrons in an atom. So each atom in its neutral state will have the same number of electrons as it does protons. So to determine the number of electrons, all you have to do is find the location on the periodic table, get that element's atomic number, and then when it's neutral, it's got the same number of electrons. So there are 4 blocks of elements on the periodic table that correspond to the 4 types of orbitals. So to start us off, you have your S block. That's these 2 groups right here, groups 1 and 2, and then helium is also a part of the S block. Oops, sorry, my pen's running low. S block, okay. So then over here, these last 6 groups of the periodic table correspond to our P block. The transition metals right here correspond to our D block. And then at the very bottom, these bottom 2 rows down here, these are going to be our F block elements. So when we write electron configurations, there is a specific filling order that we always go to. So I have that filling order right up here. So this is the filling order that will always follow. Remember, electrons fill from areas of lowest energy to highest energy. Everything in the universe is designed to be lazy. So this is the filling order that it follows, starting up here at 1s. This tells us that 1s is the orbital that is lowest in energy. But you can find an electron configuration by consulting either this filling order or by using the periodic table directly. So on the periodic table, if we take a look here, we would start up with hydrogen with the smallest number of protons and electrons in its neutral state. Hydrogen has 1 proton and 1 electron when it is neutral. Its electron configuration is 1s1. How do I know that? Because it only has 1 electron. So the first thing that this tells us is that its 1 electron is going to fill in the lowest possible energy level, which happens to be 1s. The energy level corresponds to the period that this number is in. So take a look, hydrogen's in period 1. It is also in group 1, which means it has 1 valence electron. So hydrogen's electron configuration tells us its valence electron shows up in the s orbital in the first energy level. It's also located in the S block. So the very last term in your electron configuration, in hydrogen's case, it's the only term, but the very last term in your electron configuration allows you to locate the element on the periodic table. So let's say that I wanted to do this for something a little bit more complex. Let's say I wanted to do this for something like nitrogen. Nitrogen shows up on our periodic table right over here, atomic number 7. So if I want to write the electron configuration for this, I start with my orbital that is lowest in energy. I need 7 electrons to match the 7 protons in its nucleus. So where do I start? Always at 1s, our lowest energy orbital. So for nitrogen, we have 2 electrons that are going to show up in the 1s orbital. Every s orbital holds 2 electrons. So what I'm doing here is I'm saying that checks off this section and this section. I'm going across the periodic table like that. Once you get to the end of the right side of the periodic table, you loop back around. Next up is lithium. Lithium has its electrons in the second energy level. So now we're going to go over to 2. S is the first orbital that shows up, our S block. So we're going to put 2s. If I go through lithium, that's 2s1. Beryllium would be 2s2. So I put that right there, and now S is full. Okay, now I keep going all the way over to boron here. Now I'm in the P block. So this tells me I'm now filling P orbitals. I'm still in the second energy level because I'm in the second period. So 2p. And to get to nitrogen, I go through boron 1, carbon 2, nitrogen 3. This tells me that I have 3 electrons in the p orbital for nitrogen. So this is nitrogen's electron configuration. You can keep going and keep doing this for elements that get more and more complex. You just have to keep going through the periodic table until you get to the element that you want. So let's say that I want to do this for something like gallium. Gallium shows up here. It's atomic number 31. This means it has 31 electrons as well. So let's go through our filling order. We always start with 1s, that's lowest in energy. So 1s takes us here, over to 2s takes us there. Now the s is full, so I move on to the next energy level. Loop back around to the front of the block periodic table. Okay, now I'm in 2, energy level 2. 2s, go through lithium and beryllium, 2s2. All right, keep going, cut over. Now I'm into boron and I'm in the p block. So I'm in the second energy level, p orbitals. Cut all the way through 1, 2, 3, 4, 5, 6. That takes me to neon. All right, loop back around. Energy level 3. I'm in the s block and I cut through sodium and magnesium. That's 2 more electrons. All right, keep going. Over to aluminum. Still in the third energy level, but now I'm in the p block. I'm going to fill 1, 2, 3, 4, 5, 6 more electrons, add those in, loop back around. Now I'm in the fourth energy level. I'm in the S block. I cut through potassium and calcium. That gets me 2 more electrons. Okay, now, instead of being able to cross fully onto the periodic table to get over to gallium, I have to cut through this D block now. So here's where the pattern doesn't fully follow. Scandium has its electrons in the 3D energy level. So if we look back at our filling order, what you'll notice here, as I've gone through this, I got through 1s, I went through 2s, I went through 2p3s, 3p4s, and now I'm up here at 3d. 3D is lower in energy than 4P, which means it needs to get filled next. That's exactly how it corresponds on the periodic table. So I'm in 3D next. How many electrons or how many elements do I have to cut through? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. D orbitals hold 10 electrons, so I'm going to put my 10 electrons right there. Now I've gotten to gallium, which happens to be in the P block. It's in the fourth energy level, fourth period, back to our regular pattern, in the P block, and I only need 1 electron to fill it. If you count up your superscripts, these are your number of electrons right here. This should correspond to 31. So your superscripts represent your number of electrons. Your coefficients in the front here represent your energy level. This will correspond to the period for the S and the P block. And then lastly, you have your orbitals, SPD. That's what we went to for these. These are your orbitals. So if we wanted to write this out in a little bit of a faster, quicker, shorter way, we don't have to write this full electron configuration. Instead, what we can do is we can write it out in the noble gas configuration. So noble gases, that is our group 8 elements on the periodic table. Why are they noble? Because they're unreactive. They have their valence shell filled. It has a complete octet. So it means that it has 8 electrons in its valence shell. So these things are unreactive. So what we're going to use the noble gas configuration for is to say that if we want to write the electron configuration for an element, we can simply take the electron configuration for the noble gas that comes before it, in the period before it, and we can ignore all of the electrons up until that noble gas. We just have to finish the rest of it off. So let's think about this for gallium again. Here's our electron configuration for gallium, all of that stuff right there. What's the noble gas that comes in the period before gallium? So gallium's in period 4. The noble gas in period 3 is right here, argon. So argon's the noble gas that comes in period 3. If we take a look at its electron configuration, we know that since it's in the third energy level, it should end with, the very end of it should be 3. It's in the p block, so it's going to be in the p orbital, and it's all the way at the very end, so it's filled with 6 electrons. So this is going to be 3ps. Or 3p6, sorry. So what I'm going to do is head down to my gallium electron configuration and note that 3p6 shows up right there. This means that all of this is the electron configuration for argon. So if I want to rewrite the gallium's electron configuration in terms of the noble gas configuration, what I can do is take argon and put it in brackets and say, I'm accounting for the electron configuration of everything up to argon. Then you can take the remainder of the electron configuration that you've already determined right here and just finish it off at the end. So what's left after argon? 4s2, 3d10, 4p1. And that shows you still where gallium is on the periodic table. It's just the last portion of it. So if I want to find gallium, I'm looking at the very last term, 4p1. I go to the 4th energy level, I go to the p block, and I go 1 element in, that's gallium right there. So this is your kind of quick introduction to electron configurations.